Previously, I fixed up this code and made sure it was running before I deleted this, and it looks like it's running, so I'm ready to delete this I don't know what you want to call it, less organized code than it is now, maybe. So yeah, we're just gonna, you know what, before I commit to deleting it, let me see if this, okay, yeah, so you still kind of have the same general area, it's just been slightly refactored, okay. And that's nice by having these little regions, right? It was easy for me to jump to that section. So let's take that out. And, right, we have our different initializers for the different types of global data. And we can clean this up a little bit. And the next thing we're going to want to do is figure out how to do those texel fetches, because we already have the texture uploaded, supposedly. But we also need to set the uniform as well, so maybe we should try to use our uniform container for setting the has texture kind of value. I mean, we did do all this stuff down here. We just don't want to use the unipix, but the GPU container thing. Okay, well, if we're going to initialize, if we're going to use this kind of controller to set values in uniforms in the shader, this is technically an object, right? Or not an object, but a class, right? Because it's a mixture of both data and functions. And therefore, if we're going to use this class, the code would need to be in main, right? It can't be in either of those initializers. Now the thing is main, I'd rather have that be kind of like a main, well, I guess main already calls these initializers, right? Okay, yeah, main. So that code would have to come after these initializers. Now I could have like one more initializer in this order, right? And it could maybe spiral out of control, but you know, after we initialize these objects, do we want to have something where we do we want to have some type of initializer function that comes after these? Well, we're not really. The code wouldn't be like wouldn't have the same plate structure as this, because as we are initializing stuff, right, we're putting them into containers, right? So we initialize global data, we put it in a global data container, we initialize global functions, put it in the global functions container, right? Initialize the global classes, put it in the global classes container. So if we have some other type of initialization that is, it's like more setup code, and it assumes that everything already exists, and we're just kind of like messing with it now, that would logically, I think, go into some type of other initialization code. What do we want to call that? So let's say that so I think what I would want to do is have some type of sub-initialization functions. So to manage dependencies, let's say this situation gets kind of tangled, and despite our best efforts, where we're just not, despite our best efforts, things start to get tangled and the initialization order starts to get out of control. How are we going to manage that in a simple way? So without like building a complex dependency graph or doing dependency injection or doing any of that weird stuff, how do we keep initialization order simple and manageable? So we could break some rules. So one rule that we could break right now is the idea of, having function names that have numbers in them, and we could create like a after we call it a finalizer. Well, it's not really a finalizer because finalizers are used in destructors. Well, let's go look up what a finalizer is. So finalizer meaning and code. Constructor and destructor are language terms meaning methods that define classes, while initializer and finalizer are implementation levels. Yeah, that's what I would. Yeah, so that wouldn't be proper. Okay, so here's what I'm going to do. So I have this pattern initialize global. We could just have, if you want to keep this 3-letter thing, so we could do this like ini. So it's still doing stuff with this, but we're saying that this all exists, and the new initializers need to like somehow mess with all of this, and they're relying on all of this to exist. I'm just gonna say like initialize and then global, and then I'm gonna just call it this. So I'm gonna break some rules and just say initialize global, and then it's just gonna be 001, and the understanding is going to be that these numbered ones come after the named ones. The named ones are more of, I'm going to call these more of a standard that I'm more invested in, and then I'm going to consider these like extension initializers, right? So we're just going to tack on new numbers, and so if we have some type of dependencies where we really want to initialize and set up some things before some other things, right? We can do this, and then we can make them, logically separate, right? So we do some work with all of this stuff in here, and then maybe some more work with all the stuff in here. Like we could do that, and the advantage of that could be being able to force kind of a strict ordering on initialization past what is already provided by here, right? So this is some coarse management of dependencies by ordering things by data, functions, and classes. But if we have anything that is can't be caught by this coarse initialization order we've imposed, we can be a little bit more refined and do some custom stuff in here. Now, because this is JavaScript, we can also can we do this? I think we might actually be able to do this. Like, because of function hoisting, we could actually call it above where it's declared, so we could go like this. And, right? And then what we've kind of created is we're going to maintain our linear order in the code, but we're going to like just formalize what the sections are called, right? So wouldn't be able to do this in C code, but this way, and I don't know, I'm not set on this, I'm more so experimenting around here, because you don't have to do that, right? You could just create some scopes, but this is JavaScript, so it has function scope, so just doing this is not enough to create any, like, any variables will still, like, leak out of this scope, because JavaScript has a function scope. It doesn't operate on block scope, unless you, I guess you could just use let instead, because right, new with ES6, but I'm old and stuck in my ways. So we could do this. We could, you know, so we're not taking up as much room, and we could kind of make these into like sections like that. And then we could say initialize other stuff that couldn't be handled by our course, initialization order by categories. And then maybe it notes, you know, categories, flow dat, flow func, flow flat, you know. And then, and maybe we just call it IO for initialize other stuff, not to be confused for input output. Okay, sure, why not? Right, and we are kind of like losing out on, right, we're indenting deeper and deeper. But yeah, let's just refresh, make sure we didn't like commit any crimes. So refresh, that still works. I just want a console.log on here, and also we need. Okay, so here we go. Console.log, and then we'll just put the name of the functions in the log calls. And same thing here. And then the other thing I like to do is, you know, put it around in square brackets so that when I see it in the log, I know it's not a procedurally generated string. It's hard-coded somewhere in the source. That's just my own convention. And if we refresh, check the console, and okay, so I see those two log messages. As expected, I didn't really, that was pretty trivial. Alright, the lesson here is that I called it before it was defined, because in JavaScript will hoist function declarations to the top of the containing scope. Right? And remember, this is function scope, so this function declaration gets put all the way like right here, right after this curly brace. Yeah, so that's, I guess maybe that's JavaScript's way of making it so you don't have to write a forward declaration like you would in C code. Now we could just call this afterwards, but I like, I don't know, whatever. This is just me being weird and having a weird style. Justify putting this here instead of, you know, down here. I think the point was just to have this as like a kind of like section header names, right? I don't know. Whatever. Doesn't matter. You know, we can maybe make it the more obvious sections. You could give it a little bit more padding, right? So that... Okay. So... Okay. Now, what I want to do is, I want to eventually do some texel fetches on here, but I wanted to set a uniform in the shader, and one of the but in order to let's look at initialize global classes here. We could actually create the uniform here. We have this just in case we need it, but we can actually set that uniform here. So we're gonna have a thing called it's hasmem for our has memory, and then it's a uniform U32 from that container we were working on, I believe, yeah. Or is that technically more of an object, right? Because it doesn't have any, I don't think it has any, yeah, this doesn't have any functions, so this is not a class, right? Because we used a pattern of having another object that kind of acts upon this. This GPU variable container thing, which is like, do we have a good justification for containerizing this and not just putting in the function scope? Yeah, we'll leave that up to a stylistic judgment. But yeah, so this doesn't actually go here. This would actually go in our global data, and okay, so this is global data. This is the initial values, and so we could put that right here. So that has memory uniform. And that seems like kind of a weird place to put it, but that's, we could put it there, or we could put it in our adapter graphics. That actually might make more sense, because the adapter graphics is specifically like our OpenGL code, and the shader specific stuff maybe should all go in there. And this object is a little bit more complicated than just like global data. I don't know. So what I'm saying is, let me put this over here on my other side. So yeah, and adapter graphics might actually make more sense, right? We have this adapter graphics object. We got the actual context, and then these different memory objects. So yeah, definitely looks like it would belong here. And then so we'll do this makes sense just because all this other stuff is already here. What we'll do is, because this doesn't have any dependencies, we can just say and if we do that, well, actually, you know, let's do null, and let's just make a note here. We're gonna do it all the way at the bottom. So adapter graphics.hasMemory, and that's because I believe there's a little bit of setup code we're doing. So sometimes I like to do kind of like a Java beans pattern where I construct the object and then I manually set certain properties to make the object state valid, right? So that's definitely not array thing, like a resource acquisition is initialization. That's that would be me violating the whole like array ethos. And the reason I'm going to violate that ethos is because it makes the source code more readable. Because I can actually see what those different parts are, right? So adapter graphics.has memory, right, equals new uni u32. Another possible way to do it is like you to constructor you could supply some type of named object like this. And then param name, and then param value. You could do something like this, where you have a constructor function and you just pass it this anonymous object that contains all the parameters, and that can make the code readable as well. The reason I don't really like to do this as much is it just I don't know, it just feels like it gets out of control, and it forces, I don't know, there's just something I don't like about it. Like I've tried to do, I think it's because when I try to like take this concept over to like C code, like the overhead is just ridiculous. So there's like a lot of, it's nice and makes the code readable, but it adds overhead. And so I like to just try to keep it a little bit simpler and kind of make a compromise. So adapter graphics.has mem, and it has I believe like some type of name property. So if we go and look at the uniform U32 kind of like a thing we're writing here, we have a value, and then we have a thing called varlock, where we can kind of like lock these values once we've fetched them, and we got to set the U32 name. So now that we have that, we can go back. Okay, so .varlock.u32 name equals, we'll just set it to has memory, right? So this just gives us, rather than just passing this as a constructor, right, I'm just doing it in a Java Beans kind of style. And this gives me a little bit more insight as to what's going on when I read the code, because I can see kind of like I'm peering inside of it. So that even gives me more information than if I just had like a named constructor like u32 name and then has mem. Right, it gives me even a little bit more insight than if I were to call it, this way. Now, it might not be the best way to do it, right? Because now you can construct an object in an invalid state, and I believe that's why I have to combat that problem. I do have a specific error check in the function code that fetches the has memory uniform that makes sure that this is not an empty string, because this new operator will initialize this value to an empty string, and functions that operate on this will check to see if it is in a valid state before it continues, right? Okay, so we have this thing, and we need to refresh, because there's the potential that that constructor, might have something bogus in it. That looks good. Now the next question is, technically, that is Okay, so now it's that GPU controller kind of thing. So GPU variable controller, which might not be the best name, but we'll stick with that for now. We're gonna like make an instance of one of these. Okay, so once again, like before, we want like a new function. So function new GPU variable controller, and then we're just gonna return. And can you seal a? Well, we might as well, just in case. So var GPU variable controller equals new, and then GPU variable controller, and then object.seal GPU vcom like that, and then return GPU vcom. Okay, so we're gonna return that object, and all right. We're gonna put that in our global classes, right? So in our initializer for the global classes, which is down here, and we don't have to worry about the fact that that object operates on data in here, because it doesn't need to know about the data it operates on. So GPU variable controller. Now is that proper though? Because we already said that we were gonna. So this is our adapter graphics, right? And the GPU variable controller doesn't really have much use outside of our adapter graphics, does it? Right? No, it doesn't, right? And it's specific to its form. Like everything in the GPU variable controller is very OpenGL specific. So actually, it doesn't make sense to go here. It should actually, that instance should actually go inside the adapter graphics. So we're gonna take that. And oh look, we have a slot for it right here. So we can go to adapter graphics, and we're gonna put that there. And we can make a note that GPU variable controller. Right, and then we'll just go back down to the bottom. And so adapter graphics dot GPU variable controller equals new, and then GPU variable controller like that. And we can, yep, that's there. You know, if we want to, even though we've already sealed it, maybe it will make it more readable if we note that this object should be like immutable. So we could do like a object.seal here as well, and adapter graphics .gpu variable controller, just to you know, drill in the fact that this should not be changed. And if we go all the way back up here to the top, right, because we're sealing this. Okay, if we're sealing this and this is null, then if we add something to it, right, I don't think that the added object is sealed just because this object is sealed, right? You seal this object and it seals these members, but if you add an unsealed object, it doesn't like inherit the sealing, as far as I know. Just from what I've seen, how the object.seal and object.freeze operate, I would assume that's the behavior. But you know, if you want to correct me, that's fine. Okay, so now let's take a look, make sure this is still running. Okay, so that's good, still running. And with our variable controller in place, we have our adapter graphics. We can do some more initialization code. And well, let's keep on going here. Let's not break up the code into more functions than it needs to be, unless there's some type of reason where it's just not, unless it's not possible to keep on writing linearly because of dependencies and issues like that, then we should try to keep writing linearly, right? Like, I don't care how long the function could be like 5,000 lines of code, but if there is no reason where, like, functionally it needs to be broken up, then I'm not gonna, like, artificially just break it up. You can, I'm not gonna break it up so that I can give a section of code a nice, function name that, self-describes the code. Like, I know that's, like, a clean code thing, and not to say that I agree and disagree with certain things in clean code. That's one of the things I disagree with. What is that called? Is it called, like, lexical refactoring? It's like extract and method extraction refactoring. I think it's just better to just, give sections, and rather than throw things into functions artificially. If you're not going to reuse it, just, put a comment above it, right? Because sometimes it's so hard to come up with function names and variable names. But it's so easy to write a comment describing what you're currently doing, So the mental effort, I don't think it's worth it. It's more mental effort to come up with the name, and then you destroy the linearity of your code for no reason. Like, don't destroy the linearity of your code unless you have to, right? Okay, so in here, we need to say, we need to, like, do the texture uploads, right? Or actually, these texture uploads already happened. Yeah, so, so flag textures as uploaded, so shader code will know it can safely use them. Right? That's kind of like what we're doing here. And then a ridiculous amount of commenting for just one line, which I believe is going to take our adapter graphics, we're going to take our GPU variable controller, and then it's going to be put U32, and we're going to take the adapter graphics dot the uni U32, or, well, the has memory, and we're gonna give it some type of value. Or, hold on, that's not quite how I did it. It's the input and output. That's why I put it into a container. Yes, that's why. Okay, because sometimes things are not. So I'm doing kind of a C style, or the second parameter is the return value, but it's also the input. It's like the input and the output, because the idea of, like, getting and putting is synchronization across the CPU side and the GPU side. So what we're going to do is we're going to take our does it just work with the adapter graphics? I can't remember. we'll take a look at that really quick. So put U32 is the second parameter. Is the first parameter just the adapter? Okay, so it's U32 put, wasn't it? Put U32. Yes, U32 put. My bad. So U32 put. And if we look down here, okay, yeah. So the first thing is adapter graphics, and the second thing is that uniform package. And then, like I said, I believe down here when we're fetching to cache the location of the uniform, if it's still an empty string, then we're gonna throw an error because the object wasn't properly set up. So let's go back here. So when we're setting this, the idea is we want to configure the state of this has memory object, and the put is persisting it to the GPU side. And if we use the get is going to, load this object with whatever is on the GPU side. So that's why this is kind of obtuse, but it just seemed like it just seemed like a sensible way to do it. Sometimes I'm just doing things on a hunch. Kind of like there's all these different ways to do things, and this just felt like the best way to do it. I'm sorry, I don't have a better justification. Alright, so the adapter graphics, and then it's going to be like in that varlock, and then, is it in varlock? No, it would not be in varlock because it's, it'd be like U32 value. That's what I called it. Yeah, U32 value. If I type that backwards, val U32, does it? Yes. U32 value. And that will equal 1. So, true/on. Okay, so that, we can give that a shot. Let's look at U32 put really quick and see if it makes sense before we go ahead and do this. One of the things is, because I'm kind of uncertain because of a lot of refactoring I've been doing, I might be uncertain that this OGL context is correct. In fact, I believe I'm calling it something else now. I believe I'm calling it context graphics. So if I go OGL CTX, do I have this in my notes? Use context graphics, yes. So that's telling me, and if I go CTX OGL, yes, OGL CTX, so that's telling me it's backwards. But then when I type it the correct way, it's going to tell me to use the other okay, yeah. So I'll make a little note here that, I'm going to just say AKA, and then OGL CTX OGL, and then it's context graphics or graphics context. Like these are the different ways you could spell the variable, but there's one canonical way that we're going with this, right? And we're calling it the context graphics, right? And then to make sure we haven't screwed up anything, we can say, if a not eta, so the not just doesn't show up well enough to me, so I like to be more verbose. I just don't like having a single character that you could accidentally remove and then I'm really paranoid about accidentally deleting a single character in my source code and then not being able to figure out what's screwed up. So I tend to be verbose like this, so that if you did that, you would know, maybe that's a false, right? So adapter graphics dot context graphics, and then we'll just throw, and then U32 put, and then maybe missing, like that. I don't know. Like I said, it doesn't matter too much with the error messages, just as long as it's unique enough to where you can just find it in the source code by Control-Fing for it. So with that, we know that that this the previous context object we were using is not valid anymore. So we may want to take the we may want to, wherever we're kind of using that, we might just want to we just might want to make notes about what that is. And then remember, we're going to call this context graphics, which is our OpenGL context. So we might want to also have a GL in there as well. So I'm going to do like context graphics, aka, because I'm going to have context graphics, and then aka, just to have all these synonyms. Get uniform location, and then Control 2. Okay. So do we see any other OGL? Yep. So we have. So I'm gonna take this, and where I see this, I'm gonna do the same thing. Just to make a note that this should be context graphics, and that it's also known as these other things. And will that fit? No, that won't quite fit. So we'll keep on moving. We'll just keep on kind of pasting here. Obviously, things are getting kind of verbose as we do this, but I'd rather have the code be cluttered and be able to figure out what means what. So I'm not gonna fret too much about that. Adapter graphics dot context graphics, which is the GL object, but I'm just being intentionally more general, calling it context graphics. Now maybe that's a bad idea, maybe because like it's context graphics, but it's specifically the OpenGL context. So like, why call it this? Because we already have this generalized container called adapter graphics. So why not have the why not call it OGL CTX? And you know what? I'm not sure. I'm not completely oh, actually, I know why. It's because context graphics in my terminology means OpenGL. Because there's context graphics, and then there's context compute, which is OpenCL. And then I have context BUK for the context of Vulkan. So this was just, when I wrote this, I didn't realize that I already had this synonym here. So I'm just trying to converge my variable naming. And that's why I'm disallowing. That is why I'm disallowing this thing called OGL CTX for OpenGL context, because I already use in previous code. I already used a thing called context graphics to mean an OpenGL context, and the reason for that is because CL and GL they're too similar I know it's weird, but CL and GL are just, they look too similar. And so to have a variable like this and a variable like this and have to keep on distinguishing them, it makes me kind of uncomfortable. So like graphics and compute are much more distinguishable than GL and CL. And that's kind of like why I decided to write it that way. But yeah, let's keep on pasting this wherever we see the OGL context so that we kind of know what's going on when we see it. And OGL context, we'll replace it with the context graphics. And then I think we've refactored that out of everywhere it's used. Oh, one more place. And so take that. And do we have enough? No, we almost do, but not quite. Okay, so that's context graphics. And you know, while we're here, since we're taking all this time, we could take the time to add that error checking to see if the object exists or not, because we did refactor that. And where did we put that? We had like that missing whatever message, right? We could you know, put this in more places. U32 put, and then yeah, we could do that. And really, this should go at the start of the function. So we should probably put most of our error checking right at the top. That EC error checking inputs. The thing is, right, this can make things very cluttered. And some people say not to put a whole bunch of error checking in your code because it clutters the code and it kind of like wrecks the flow. And then also it technically you could say that the error checking is a separate concern and therefore we're violating separation of concerns. But for me, I think that it should be, that the error checking kind of like gives me a little bit of insight about what the code is about. Like this gives me a little bit of insight. And then also, it's by having it inlined, the error checking inlined, it's harder to remove it from the places you've put it in, right? And I want to err on making it very difficult to dismantle error checking rather than make it hard to I don't want to make it easy to dismantle error checking, right? But because I've done that right at a later date, like it's going to be, if I eventually want to make like a debug mode, right, and then I have to like wrap all of this stuff in an if debug or do some major overhaul to like remove the error checking for performance, I would rather that be a very hard feat to pull off than to let people have an easy time removing, you know, the code that's trying to protect the integrity of the execution. Right? Because honestly, what's going to happen is we're going to be like, oh, we'll remove this later, or we'll add a debug mode wrapper around it later, right? That's never going to happen. Later is never going to happen. It's always going to be this way, right? There's nothing as permanent as a temporary change, right? So using that philosophy, if there's nothing as permanent as a temporary change, I would rather err on the side of, having that error checking put in there like this rather than having a way to disable it. Because what happens if your temporary change is disabling error checking because you put like a kill switch in there, and then something goes wrong and you have some type of bug, and now every time you turn on the error checking there's a bug, so you're like, you know what, we'll just temporarily keep the error checking off from now on, and then next thing you know, error checking is no longer in your project because you kind of made a temporary change to turn it off. So I don't want a kill switch. So it's by design that it's obnoxious and inline, is what I'm saying. Oh god, I have not been... I'm gonna stop recording.